All right, it's Friday, and I always like to put out a video of what I'm working on. I've been getting knee deep into agentic pen testing, obviously in light of the capabilities that the Mythos LLM is being described. And I wanted to share with you what this really means for the pen testing space, particularly as it relates to where we've been with automated pen testing and where we're going. And I'll also show you a clip, an agentic pen testing solution we'll put on our webpage for free for you guys to work with that demonstrates some of this next generation capability. Let's start with automated pen testing. The analogy I like to make is automated pen testing is like the script kiddie approach that emerged, in the 2010s. So prior to that, we had elite hackers, as we called them, that, really were hacking for fun and profit, basically showing off their skills, either finding 0 days or building novel exploitation capabilities. And eventually, of course, it kind of became industrialized with toolkits like Cobalt, but then ransomware gangs, of course, with their weaponized toolkits. And that essentially also what happened on the defensive side with automated pen testing. And so, you would note with most automated pen testing approaches, they're running a fixed set, a checklist, if you will, fixed set of tests against every device. If they have any sophistication, they might differentiate between clients and servers, but largely they're ignoring the context of the environment. Another key thing is amnesic execution. And what this really means is every time they run a test, it's treated in isolation and there's no adaptation based on what they actually found. And then finally, the results from automated pen tests oftentimes look like the results from a vulnerability scan. You end up with long lists of vulnerabilities and a lot of noise, and now you're left to figuring out what's the needle in the haystack. So if automated pen testing is like the script kiddie approach, well, agentic pen testing is like a souped up red team on steroids. Today, the agentic pen testing capability is like hiring an elite red team from a government agency. Some of the key breakpoints from the pen testing is first, you've got adaptive reasoning. We'll talk some in a minute on the React cycle, but basically being able to on the fly based on what the agent has discovered in its initial test and the environment it's in, taking into account context. Another significant leap ahead capability is chained exploitation. It's not just finding a vulnerability and an exploit for that vulnerability. It's about chaining exploitable vulnerabilities to reach an objective like full system compromise, basically building a ladder from initial access to full compromise. And then finally, something that I've been working on is this concept of persistent learning, leveraging Carpathy second brain, which I talked about last week in the context of sales intelligence. Well, you can also apply it to pen testing. So every pen test you run creates learnings, and every time you run a new pen test, you start with those learnings. And obviously you curate those learnings so there's not too much noise in the system. But what you find is over time, your pen test gets very smart the more pen tests you run. So let's talk about automation versus agentic intelligence. So Kraken Agentic is the name of our agentic pen test that we're going to release for you to try for free. But, as a core approach, typically your automated pen test uses a fixed checklist, whereas agentic uses adaptive reasoning. Instead of acting on the finding, basically automation says, I found an issue, and then repeats the same script over and over on different machines. With agentic, we're able to find an exploitable vulnerability, pivot, exploit, and chain attacks. In terms of having memory, basically automation starts with zero memory, whereas agentic has persistent learning from one run to the next, compounding its learning. And that's really significant leap ahead capability. And then finally, the results you'll see from an agentic pen test are confirmed attack paths with demonstrated impact, which is exactly what you want. So let's talk about compound learning. This is a key capability that AI brings to the table that we're able to apply across different domains. Here, we basically have two concentric loops. The inner loop is within a given pen test, you have the react cycle, which is reasoning and acting on that. And basically, anytime you're running a test, you look at the result from that test, you then choose the correct tool to exploit that result, and you iterate until you reach either your objective or you reach a breakpoint and say, well, I'm not learning anymore. That's inside of a single scan, and you continue your iterations. Now, once you're done with your pen test is where you save your learnings, and that's what we call the vault. So it's a persistent knowledge base that accumulates learnings from pen test to pen test. So here again, talked about the inner loop, the OODA loop: observe, orient, decide, and then act. There's some examples there. And the outer loop takes advantage of this vault. I actually described it last week, but basically you take every log from your pen test, you store it in your vault as a raw scan record, and then use an AI to build a living wiki, which essentially captures what are the winning patterns that work from this pen test, and obviously what were the dead ends. So we learn from that going forward. And then, every 10th scan, in this case, we do some curation to rebuild this wiki autonomously so that we have high signal from run to run. Now, how does this work in practice? So when you put in a target, you identify, in this case, the cloud environment of the web app. We then query the vault with the target profile. It then returns essentially a prompt that says, okay, here's what you used. These were the learnings. And then you execute against that. So here's what an agentic pentest looks like. First, you would start with recon, where you map the target. Second, cloud detection. So our capability goes beyond your typical web service pen test, in that we actually look to get outside the web server and actually compromise a cloud. You'll see that. Based on the environment, we now query the vault and say, hey, give me your learnings from prior pen testing for this kind of environment. And now you run your attack loop, and we give you the ability to configure how many iterations of the inner loop, the OODA loop, you want to run. And again, this is something you can configure, but at every loop, it's iterating based on what it finds. It chooses the appropriate tool, and it continues to iterate until either it achieves its objective or it fails and moves on. After the pen test is run, we update the vault with the learnings. Learnings include negative results, which is also really important, and then we generate a report. So this was an example of a full cloud compromise. We started with the server-side request forgery vulnerability, extracted a storage key from metadata, found an SSH key, got VM access, able to get the identity from Azure, and guess what? We're now own the tenant, right? So that's exactly what you don't want to happen, fully automated through agentic pen testing. You can only imagine how far an automated pen test would go. These are the different categories that we're analyzing today with the Kraken Agentic Pen Tester. If you're familiar with web services testing, these categories will look familiar to you. And then we did some testing in terms of what does the compounding effect do in terms of performance, and it was truly remarkable. We found that the capture rate on the benchmark actually doubled from the first run to the second run, because the second run, the agent learned from what worked on the first run. And of course, eventually, your gains will begin to level out as you get more and more, but you do continue to learn on every pen test, which is incredible. And this is basically how we look at the capabilities from a level 1 attack surface analysis, level 2 being able to gain partial access, maybe there's some data credentials exposed, level 3 confirming an exploit, but we don't stop there. Level 4 is full compromise of the cloud infrastructure. Yeah, I don't think you have to be beating this horse, but basically being able to train an agent to act like a human red test allows humans to focus on what it's really good at, which is design of how do you secure this network. And what does this all mean? Well, I think what we're going to see is agentic is going to spell the end of the script kiddie era. these kind of capabilities will fall into the hands of adversaries. And what we tell our clients, our partners in the MSP space is you need to get out in front of it, right? With coming, you need these capabilities. You need to be deploying them before the adversary does so that you can identify these attack paths and these attack chains and remediate them. And again, what we're about at ThreatMate is finding and fixing these vulnerabilities autonomously. Anyway, I hope this was useful. We'll show you next how we actually ran this in practice so that you can do the same thing, and look forward to hearing your comments. We've covered agentic pen testing and the capabilities that really is a leap ahead from automated pen testing. I now want to show you this in action. So our UVA student intern team built an initial prototype for agentic pen testing, which is fantastic. I'll tag them below in the post. We've since expanded some of these capabilities, in particular to include the compound learning that we talked about. So this is the Kraken Pentester. You can use this to test any web service. And again, it is a very real pen test, so make sure that you are authorized to run this pen test. I'll run it on Azure Goat. You can look it up. It's a web service that runs on Azure with known vulnerabilities. So a good way of seeing whether the pen testing is working. From a model point of view, I'll choose Opus 4.6 as our pioneer model. This is used to actually solve for any hard challenges, and to be cost efficient, we'll use the Sonnet model to actually execute the work once we determine how best to solve. So again, it's that react cycle, reason, and then act based on what you've learned. We'll choose up to 50 iterations per attack step. And you can see here we support Azure Cloud Services. We'll soon support GCP and Amazon. So with that, I will go ahead and start the scan. And over here is the live attack feed. It will begin to do its recon of this website. And I won't bore you with the details here, its analysis. I will come back and show you where it ended up. Okay, this is nice to look at. This is a PDF version of the pen test report. So this was the website that was tested. You can see the bottom line here is level 4, full compromise. And here's executive summary. So this ran a total of 2 minutes and 46 seconds. We used the Opus 4.6 model. Our total token cost was $1.62. And here is the narrative of what happened. You can see that we provide an executive summary, then show the attack chain, starting with the storage access blob, and we're able to gain Azure CLI access. And step 3 was function app enumeration, extract the key in step 4. And you can see here we were able to retrieve the default function key and the master key, which was then used to complete the full compromise. We also will show you the evidence. That's always key in any sort of pen test, to be able to show the actual evidence, so you know if you're ever being audited, you need to be able to show that. So this is awesome. Full cloud compromise is really significant. You own the tenant as well as the field attempt. So all of this data gets written to the vault, which then becomes key for future learnings. And you can see we got there pretty fast. So next is, what do you do now that you're able to demonstrate full compromise? What can you do to prevent this? And that's our job, right? As defenders, we don't just break into systems, we fix systems. So we come out with the full recommendations on how to fix this. Anyway, I hope this was a useful demonstration. As I mentioned, we will be publishing the Kraken Pentester on our website as a free tool. Please don't run up our API bill too much, but we'd love to get your feedback. Thank you.